Okay, everybody. This is actually the second video I've made. Optimization was actually the one I tried first, but this will be the first one. Hold on with this. Let's do this. Okay. This will actually be, okay, y'all this Zoom is crazy. Okay, this will actually be the first one I want y'all to try. Okay, so we're going to be doing max and min problems. Okay, now, the second video I made, optimization, is kind of like the second half of this. It's basically figuring out maximums and minimums of each thing. So like the inside of the notes, this will be where, and sorry, I have to check every like 4 seconds to make sure y'all can see me. Okay, these will be what the next lesson is about as well. Now, this first thing we didn't do before, and we're going to try our luck out with it now. Okay. This is the kind of thing where you got to pay attention, okay? And I knew, like, y'all would probably want to see me do this before you had to try on your own. Okay, so the figure shows the graph of f prime. So, like, this is the graph of the derivative. Like, if you had x squared, this would be the graph of 2x, okay? Like, this is the graph of the derivative, okay? So, again, we're still on derivatives because we had to go back and get some things, and I thought the applications would be a lot easier for me to leave for you than I figured y'all wouldn't want to use substitutions by yourselves. So this graph is the derivative. Again, if the original function is x cubed, this graph is 3x squared. Okay, so we're going to refer to it as g just to cut down on some confusion. So each of these g's is talking about the graph of f prime. Okay, so f prime, that's what this is talking about, okay? So what we're going to do is we're going to practice looking at this graph, okay? F prime of x equals 0 is where g equals 0. So you're looking on the graph for where the graph equals 0. So the place for the graph, not the derivative or anything else, the graph, okay? Yes? All right? You're looking at places where that's 0. So that's where it crosses the x-axis. So we're talking about right here, right here, right here, and right here. Okay, so that's what I'm listing. -2, 0, 2, and 4. Okay? Let's find this stuff first, and then we're going to talk about what everything is. Okay, just so we don't get lost in translation. Okay? Where it's greater than 0. Again, we're talking about the graph for all three of these, okay? So where is it greater than 0? Its output value is greater than 0 where it goes above the axis. Does everybody see that? So like this interval from -2 to 0, look, it's above the x-axis. And then again, from 4 to infinity. Okay, so where it's less than 0 will be where it's below the x-axis, -infinity to -2. 0 to 2, and you have to split that up, and 2 to 4. All right, good? Because you're just looking at the picture. If it's above, if it's below, where it's 0. Now, even though it says double prime right here, we are talking about the derivative, the slope at g. So we're talking about g prime on all these. Right here is where we're talking about the slope, the derivative of our existing graph. So, sorry, gotta check the time, y'all. Okay. So where it's 0 is where the slope would be 0. So these flat places right here. Can y'all see that okay? All right. So I have -1, 1, 2, 3, and 5. Hopefully that purple showed up okay. All right. Now we're going to look at the slope. Okay, so let's follow. Look at which way the line leans. Okay, you'll see how this is going in the positive direction. So this would be for -infinity. Whoa, dude, my infinity kind of messed up. -infinity to -1. And then look from 1 to 2. And then look from 3 to 5. Okay. Right here, you're looking for where the slope is decreasing. So that's as you move to the right, it goes down. So like trace it with your finger. So this is what I'm talking about right here. From -1 to 1. From 2 to 3. And then look from 5 to infinity. Okay, that's just looking at the graph. That's all that is. Here, let me move this a little bit. Okay. Sorry, y'all. Okay. So now here's the whole reason we did that. You'll see this part down here. We're going to draw a potential of what this graph might look like. So they gave us the graph of f prime. I almost said f of x, y'all. Sorry. They gave a graph of f prime, which is the derivative of f. Okay. They gave us the derivative. Now we want to draw y equals f of x. That's what they really want. Try to find a color that's not that one. Okay. Look. There we go. All right. So there are multiple correct answers to this. So sorry for all my picky people. Okay. There are multiple correct answers to this, but your graph should be having the same kind of movement. What we're going to do is we're going to take this information and put it down here. This actually gives us a whole lot of information about f, okay? Even though we got the information from f prime, it gives us information about f. So here's what we're going to do. Look, all these places where the derivative equaled 0, the derivative of f equaled 0, those are your possible maxes and mins. Places where the derivative of our graph is greater than 0 is going to be increasing. The derivative of the graph we're trying to make, look, we're trying to make f. Well, this derivative of f was less than 0, so this will be places where we need to have decreasing values whenever we make our picture. Okay, the second derivative, these might be a point of inflection. And then, you probably guessed it, concave up, concave down. There are the properties for our graph, and there are the intervals where it's supposed to happen. Okay, so I gave you a starting point just because you got to start somewhere. Okay, look, f of -2 equals 0. Okay, so that is the point. Remember, that's x comma y. That's the point, -2 comma 0. Okay, so, we're going to start here. That'll at least give us kind of a place to, got to start somewhere. Okay, draw a possible graph of y equals f of x. Before I start drawing on here, I'm going to take all this information and try to put it on here the best I can so I can plan what my shape is probably going to look like. Okay, so first thing I'm going to do is I'm going to highlight all my possible maxes and mins. I'm just going to do like this, like -2, 0, 2, and 4. Those are my possible maxes and mins. Okay. So when I'm drawing, I know that like it needs to kind of flatten out right there. Possibly, let's see what increasing, decreasing does. Okay, look, the next things I'm going to do, I'm going to go ahead and put this information on here. So this information is -2, I'm just checking the time, -2 to 0, and 4 to infinity. Those are increasing values. So look, -2 to 0. And then 4 to infinity. Just kind of draw like that. No, this isn't the graph. This is just me planning ahead. Okay. Now for decreasing, -infinity to -2, 0 to 2, and then 2 to 4. Okay, hold on. It's giving me a time warning. We're going to do concavity here in just a second.